right, so we've got our pipe. Essentially what we're going to do is we're going to recreate this blow-off valve setup, except instead of using a Grady Type S or Type RS flange, we're going to use a V-band flange for a Tial wastegate. Because this is the boost pressure pipe and it's higher pressure, we do need to put a little bit of a bead roll on this. We're testing out sort of a little bead roller crimping device that we made by cutting in half a Harbor Freight snip. Let's go ahead and test it out on this pipe. Let's get everything we need to get done. All right, that's just a couple of squeezes there, but you can really see it's actually a pretty good bead roll. It's not dimply or anything, and they just connect really easily to the next one. You just gotta give it a good squeeze, and it works through, and it works pretty quick. And that's a little custom DIY tip. Hopefully you have a bandsaw. If not, you can work away with a bench grinder. It'll take a lot longer, possibly an angle grinder if you have one. My angle grinder's in there. I figured this would give me a straighter and easier cut to work with. And it was straight, but the blade sort of twisted when it was cutting, so it ended up cutting kind of a weird curve to it, but oh well, it worked out fine. And I'm actually super happy with that. Like, that's actually usable. All right, so that's gone around and crimped our bead roll in there. And as you notice, it closed off the end here. We have an exhaust expander that we're going to throw in here, which is going to essentially spread this back out. If you don't have that, or you didn't want to do that, you could also put this on like a grinder of some sort, or use a Dremel and cut off this this inner edge here. If I had actually pulled up when I squeezed, it wouldn't have distorted the pipe inward as much, and I wouldn't have had to go back around and straighten everything out. You want to make sure you don't overdo it. So on this pipe, you can see we got a little crack there because we squeeze a little bit too hard. Sometimes you get carried away. It can be fixed pretty easily, and that's also where the coupler goes. So, I mean, it shouldn't leak past it, but mainly this is just to stop the coupler from being popped off. The other thing you can do, what I recommend, and I'll be doing this here in a bit, is on the edges here, I'm gonna just round off those corners, because that rounding off the corners will help so you don't tear the aluminum right there, because aluminum is pretty brittle and it's not a fan to being stretched. We'll round that off there. We'll round off the back side of this as well, and then the back side of this as well. The other thing you can do is do multiple passes instead of trying to do it all at once. Cost was $7 plus tax at Harbor Freight. If you have a 20% discount coupon or anything like that, then of course it'll be even less. You know, you'll save another $1.40 roughly, and then plus tax. What we're also going to do is we're going to cut our own bung. We've got some aluminum, just sort of a blank 1 inch that we're going to machine down and then weld onto our pipe. And then from there, we're going to be able to drill and tap our fitting to 3/8 NPT so we can fit in our intake air temperature sensor. Come on, you died right there? Bastard. So I was having a little trouble earlier getting this O-ring to stay on. And in case you're having the same thing, it kind of keeps rolling or keeps popping off. What you want to do, so normally you'll try and put it on like a normal O-ring, and it just keeps popping off. So basically what I did, I rolled it inward a little bit, and then kept it pressed down, rolled it inward, kept it pressed down, and then I kind of gave it a good squeeze down. And now the O-ring is in place. So we want to install this way, and then we're going to throw on our valve. Now we haven't tightened up the top here just yet, but we still want to make sure we put the nicest side out. So some of the anodizing has been a little scratched off right there. And then now, we gotta take our V-band, figure out which way we want it. I want the bolt going away from the throttle body. Main reason I want that is just so I have clearance, so I'm not trying to, if I need to take this blow-off valve off, I'm not running out of space or anything. So we'll just pinch that. Get our bolt fed through. If you don't pinch hard enough, the angle of the bolt is a little bit more difficult. Normally you can get these finger tight if you can squeeze the clamp hard enough. There we go. So now I got it aligned just right that I can finger tighten it. And grab some pliers here and finish this off. Should have grabbed my socket. That would have been, oh well. I think those are down in the garage. That's basically it. It's actually a pretty huge valve. Probably way more than I need. The Grady seem to be working all right, or the Grady Type S knockoff seem to be working all right, but I wanted to sort of take the next step, and I heard one of these on Facebook, and I think they, at least on that person's car, sounded amazing, so I wanted to see if I can get that sound for myself. All right, so what I've done here, I went ahead and drilled out the hole. You can see there on the inside. Basically what I ended up doing was putting the clamp on it here just to crush it a smidge flat. Not going to affect flow or anything, but just so we get a really nice contact on our AN fitting. And that's going to allow us to do a really nice weld on there. So we'll show you the fit up here in a sec. All right, so here's our hole already smoothed out. You can see not a lot of blood there. And that's going to fit right there. This is going to be for our vacuum. This clamps up to the turbo on this side, and this right here will pull our vacuum on our catch can, which will ventilate our crankcase as well as our valve cover. So it goes to the valve cover fitting, and then by pulling vacuum on the valve cover, it pulls vacuum on the crankcase. All right, definitely not my best weld, and certainly not my best aluminum weld, although my aluminum welds are noticeably shit. But I should be good. I have a little bit of a divot right there, but I don't see any cracking, which is good, and I don't see any like pinholes or anything like that. They should be all filled. It is a vacuum section, so it's, you know, sucking into the turbo this way, that way, right? So it's coming this way. So it shouldn't be a big deal if there is any pinholes. You would just be bypassing the filter, but at the same time it's super tiny, so it's not the end of the world. It works. So we're gonna let it cool down, and we should be able to throw it on the car. All right, one of the dumb little things that bothers me about this car is that the switch, wait for this beep, we get it, we're not wearing a seatbelt. The clutch master cylinder actually has a built-in magnet in here, and that magnet is what essentially causes the switch to engage the starter motor. The challenge is that sensor, is this one up here, is a pain in the ass to modify or make work. And so instead of yet letting the magnetic kind of piston or whatever's in here trigger that, I've decided to bypass it and wire up a switch. So I've got a little diagram I made of both the wires here as well as the switch operation and what to connect to. And essentially what we're doing is we're hooking up this micro switch to allow us to trigger the clutch. So when we push the clutch in, That's what we'll get. And what that allows us to do, see how when I push the starter motor or start button, nothing happens, just shuts off. So I turn it on, push my micro switch, and it tries to engage the starter motor. Battery's kind of dead, so it's not working, but you get the idea. Starter motor engaged. And so the main reason why all of this is necessary and why we can't use the OEM master cylinder, the slave cylinder that we did it worked okay, but we didn't have enough stroke. So what we decided to do was change the master cylinder to an OEM master from a Mitsubishi Eclipse. So this fixed not only our stroke ratio, but also allowed us to have an adjustable clutch pedal, which you can see the adjustment up there. And then this is the bracket and how it's been mated up. And it works pretty well. You might have seen this on Instagram. I have some better pictures of the whole breakdown, but essentially it works. And having this originally was as a hard cable, but the problem with the hard cable is you can't bleed it properly because you need to flip it. Because it's an inverted setup, you actually have to flip the master cylinder downward to get all the bubbles out, bleed it properly, and then you have to flip it upwards to mount it and install it and have it hooked up with the pedal. And so that means that we really need to have some sort of a micro switch so that we can trigger our starter motor. Not a lot of places to mount stuff in here. All right, this is the simplest way that I can think of to hook up two switches. Just tied it into a screw, and it can't really rotate back here because there's a piece of plastic in the way. And then it can't rotate this way either because of the pedal that's in the way. So that's good for launch control and flat shifting. So, sorry, this one is good for launch control and flat shifting. This one is for starting the car. So that's simple enough and done. Check that off the list. Thanks for watching, subscribing, liking, and commenting on my videos. That's a great way to help support the channel. If you want to crank your support up a notch, consider becoming a patron over on Patreon. You get early access to videos, and you get to have your name immortalized here in the video, and I hope that you consider joining them. Alright, thanks for watching the video, everybody. Make sure to stay safe and be healthy, and of course, keep modding your cars.